Today let us see method of variation of parameters, and this method is useful to find the solution for the equation of the form d squared y by dx squared plus p of x dy by dx plus q of x into y is equal to x. And here this p, q and x are functions of small x. Let us find the particular integral, and we are going to find it like a proof. So this equation can be written as y double dash plus p into y dash plus q into y is equal to x. If this gives, it gives particular integral as minus y1 integration of y2x by w into dx plus y2 integration of y1x by w into dx. If this is the particular integral where y1 and y2 are solutions of y double dash plus py dash plus qy is equal to 0. So as because this is a proof, let me consider this as equation 1, this as 2, and let this be 3. And here we know that y1 and y2 are solutions of this equation. And what about this w? This w is equal to the determinant of y1, y2, y1 dash and y2 dash. And this determinant is called the Wronskian of y1 and y2. So let us prove this. We are going to prove that the particular integral is this. Okay. Consider this equation 1. So if there is an equation, the solution will have a complementary function and a particular integral. So let us consider the complementary function as, let the complementary function of equation 1 be, so let me indicate it as yc, that is equal to c1 y1 plus c2 y2. Here c1 and c2 are constants. Likewise, let us consider a particular integral. We assume that the particular integral of 1, we assume that the particular integral of 1 be, let me indicate it as yp, and this is equal to uy1 plus vy2. And if you see here, this u and v are functions of x. U comma v are functions of x. So in order to find the solution, so if you notice this equation, we need y, y dash and y double dash. If we consider y as uy1 plus vy2, I need y dash and y double dash. So let me differentiate this equation. Let me consider this as 4. So now let me differentiate equation 4 with respect to x. So here u and v are also functions of x. So what we get? Yp dash is equal to u y1 dash plus u dash y1. If I differentiate this, it is u dv plus v du plus v y2 dash plus v dash y2. So I am getting this. What we are going to do here is, we are going to consider yp dash as u y1 dash plus v y2 dash. So on assuming, we are going to assume that u dash v1 plus v dash y2 is equal to 0. So I'm going to consider u dash y1 plus v dash y2 is equal to 0. So let me take this as equation 5 and let this be 6. Now we have y dash, and what about y double dash? We need y double dash. So let me differentiate this again. Differentiating 5, equation 5 with respect to x, we get yp double dash. So this will become double dash is equal to u y1 double dash plus u dash y1 dash plus b y2 double dash plus v dash y2 dash. So this is our y double dash. Now we have y dash and y double dash, and I'm going to substitute everything in my equation 1. So let me mark this as 7. Substituting 4, that is your y, 5, equation 5 is your y dash, and equation 7 is your y double dash in 1, equation 1. My equation 1 is y double dash plus p y dash plus q y is equal to x. So let me substitute everything here. That is, first is our y double dash, that is u y1 double dash plus, let me take this first, plus u dash y1 dash plus b dash y2 dash plus p into y dash. So p into y dash will be, what is your y dash? u y1 dash plus v y2 dash plus q into y. So our y is u y1 plus v y2, and everything is equal to x. So let me take u outside. So if I take u outside, we'll be getting y1 double dash, and here I have one u plus p y1 dash. Here I have one u plus q y1. Okay, that's all. Plus let me take v outside. This is going to be y2 double dash, and here you have v, so it is p y2 dash, and here also you have one v, that is q y2. And let me write the rest of the terms, that is plus u dash y1 dash plus v dash y2 dash, and this is equal to our x. So if you see, we already know that y1 and y2 are solutions of this equation. So our y double dash plus p y dash plus q y is equal to 0. So this will become 0 and this will become 0. So this is 0, this is 0. So this can be written as, that is u dash y1 dash plus v dash y2 dash is equal to some x. Let me mark this as equation 8. So now we have two equations to solve. One is this u dash y1 plus v dash y2 is equal to 0, and the other one is what we have obtained now, u dash y1 dash plus v dash y2 dash is equal to x. Let me solve equation 6 and 8. Solving 6 and 8. So what can we do? We are going to just solve it. So So in order to solve for u dash and v dash, let me multiply this equation with y1 dash and this equation with y1, so that I can cancel one term. So 6 into y1 dash and 8 into y1. So this implies u dash y1 dash plus b dash y2 y1 dash is equal to 0, and this implies u dash y1 dash plus v dash y2 dash y1 is equal to, this side you have x here, so it is y1 into x. Let me subtract this. This will become minus, this will become minus, and this will become minus. So I can cancel these two terms, and here it will be v dash y2 y1 dash minus v dash y2 dash y1 is equal to minus y1 x. So what about our v dash? So let me take v dash outside. It will become y2 y1 dash minus y2 dash y1 is equal to minus y1 into x. Now v dash is equal to minus y1x by y2 y1 dash minus y2 dash y1. Now look at this. This is the Wronskian determinant, but we need to alter this a little. Let me take this negative sign outside, so that I will be getting y1x by y1 y2 dash minus y2 y1 dash. So this will be the Wronskian determinant. So this can be written as y1x by w, where w is equal to y1 y2 dash minus y2 y1 dash, that is the determinant y1 y2 y1 dash y2 dash, and this is the Wronskian of y1 and y2. So now we have v dash. So my v dash is equal to y1x by w. So how to find u dash? For finding u dash, let me take equation 6. I'm going to substitute this v dash in equation 6. Substituting v dash in equation 6, we have u dash y1 plus y1x by w into y2 is equal to 0. So this implies u dash is equal to, so here I can cancel one y1, and the rest of the term I can bring to that side. I can take it to that side. That is u dash is equal to minus y2x by w. So I have my u dash here, and this is my v dash. So I can write u as, so what is u? I have to integrate this. I can write u as minus integration of y2x by w into dx, and my v is equal to integration of y1x by w into dx. So now we have our u and our v. Let me substitute it in equation 4 in order to get the particular integral. So substituting u and v in equation 4, this is my equation 4. It is y is equal to, or the yp is equal to uy1 plus vy2. So what is our u? Our u is minus integration of y2x by w. That is minus, I have one y1 here, y1 integration of y2x by w into dx. Sorry. Okay. Now my v is equal to integration of y1 x by w. Let me substitute my v here. Plus we take y2 outside, integration of my v is y1 x by w dx, and this is our particular integral. This is the particular integral that we need to find. Hence the theorem, that is particular integral is equal to minus y1 integration of y2 x by w dx plus y2 integration of y1 x by w dx. Hence